Alright, so as mentioned earlier, this is the second part of the video, which is all about informed search algorithms. So informed search algorithms, it uses domain knowledge in the form of heuristics, which is an estimated cost, to make smarter decisions during the search process. And these heuristics estimate how close a state is to the goal, guiding the search more efficiently. Let's take a look of the definition of the greedy search. So again, informed search algorithms, we have greedy search and we have A star. So si greedy search is a heuristic-based algorithm that selects the path which appears to lead most directly toward the goal. So yung decisions niya is based solely on the estimated cost from the current node papuntang goal niya. So it will ignore the cost already taken to reach the current node. So I will explain that later on how will that happen in uh, real life scenario. This approach makes greedy search fast and memory efficient as it only focuses on immediate gains. So for example, we have this greedy search here. Say for example, si initial state natin S is your home. Okay? And then yung goal state natin is that we would want to go to school. Say that is MMCM. So from our home, papuntang MMCM, ang heuristic or estimated cost niya is 7 kilometers. Just an example, okay? Now, from that estimated cost, how will we travel from each of the nodes using the greedy search algorithms? So, let's start. First goal or first state, we will compare S to A, that is from S to A, that is 9 in heuristics, S to D, that is 5. Okay, of course, S to D is lesser, right? So S to D, papuntang B, that is 9. S to D, papuntang E, that is 8. So that's 5 plus 3, right? Sige, step by step. So that is 5 plus 3. Ito naman siya, that is 5 plus 4. So SDE. Next, since wala namang ibang path, no? So of course, SD, because 8 is lesser than 9, so SDEG is our path. And that is 5 plus 3 plus 0, which is 8. So estimated cost is 7, but using greedy search, the path cost is 8. Okay, so therefore our path would become SDEG with an estimated cost of 8. So let's have another example using greedy search algorithm. So let's create another table so that it's easy for us to understand. Okay, so this is our from our initial state, padulong goal state, papuntang goal state, we have 40 as our estimated cost. So let's find the path from S to G using greedy search. So first, that is say A to D, that is 35. Then A to C, that is 25, which obviously is the least among the children that the A is going to visit. And that's A to B is 32. So of course, our path here is A to C. So A to C is shorter from all of the children that it has. So A to C now, we will visit F. So visiting F first, that's 25 plus 17, and that is 42. AC, it only has two children, F and B. So ACB, that's 25 plus 19. Obviously, that's 44, I think. Yes, 44. So, of course, we will choose 42 as our shorter path. So that's ACF, yung shorter. And then there is the goal. It's 42. So therefore, our path would be A, papuntang C, papuntang F, papuntang G, with an estimated cost of 42. Yeah, that is greedy search. Okay, next is the A-star search. So this is commonly used for sa mga katokong gina-mention na mga Google Maps. We have one thesis from the CE, no, to like map a mountain, kung ano yung path na gagawin from that mountain or from that mountain ba ng term. Basta mag-watch path sa mountain using A-star search. No? So, A-star search tree search also uses f of n is equal to g of n plus the heuristic of n, h of n, evaluations, but it treats the search space as a tree, which means that it doesn't track already visited nodes. So ito yung maganda sa star. Every path is explored independently even if it leads to the same state. This can result in duplicate work and of course a larger search space, especially in graphs with cycles. Although it's simpler to implement A-star search, may be less efficient is typically used when the search structure is naturally a tree or when memory constraints prevent maintaining a closed list. So for example, you would want to have or to find the path to reach S to G using A-star search. So as mentioned earlier, we have an estimated cost of 7 here, but in A-star search, we have yung G of N, this one. So si G of N is the cost from the initial state. Yung cost niya talaga to the initial state papuntang state at the current node. So for example, the G of N here from S to A is 3. Okay? So that is the cost niya, ng cost sa initial state papuntang current node. So, example, we start with S here, which is the 7. Heuristic cost niya patutang goal is 7. But G of X is 0 since wala pa man tayong na-visit na node. Sabi nga kanina, it's the cost from initial state to the state at the current node. Next, we would want to visit is S to A. We have 3 as our cost from initial state papuntang A, right? And ang heuristic natin dyan, our h of x is 9. And if we add both, that becomes 12. Okay. If we compare it to, it's another path to the node D, which has a heuristic cost of 5 and an estimated, a heuristic cost of 5, and it has a cost which is 2. Okay, so therefore it is 7. Of course, we compare 12 to 7. 7 is lesser. Therefore, we traverse from S to D. Now, D has now children B and E. So would we traverse to B or E? So let's try to find out. If we traverse to E, so S, D, E, we have a cost. SDE naman tayo. So sa SDE, we have an actual cost of 6, 2 plus 4, but a heuristic cost of 8. Heuristic cost pala. From D to E, heuristic cost pala niya is only 3. No, which is here. It's 3. So 3 plus 6, that is 9. So again, from S to D to E, its heuristic cost from S to E is 3, no? Using SDE path. So that is 3 plus the actual cost of 6, that is 9. Tapos, sa SDB, hindi niya na-visit ang SDB. SDB, that is, nag-visit na siya ng C agad. Tama pala. So, 7 yung SDB. SDB 7, SDE is 9. So, balikan ko ha. It might be confusing. Once again, from S to D to B, we have a heuristic cost of 4, but an actual cost of 3, 2 plus 1, so that is 7. From S to D to E, heuristic cost of 3, but it has an actual cost of 6, so that is 9. So 3 plus 6, that's 9. Now, since 7 is shorter than 9 or lesser than 9, then we visit SDB, and B has the children C and E, right? So let's visit SDBC first. From SDBC, heuristic cost of 2. As you can see, S to C is 2. Then yung actual cost is 2 plus 1, 3 plus 2, 5. So 3 plus 2, that is 5. So 5 plus 2, that is 7. And then SDBE. Okay. So SDBE is 3 ang heuristic cost, correct? And then yung actual cost niya is 1 plus 1, that's 2 plus 2, that is 4. So 4 plus 3, that is 7. So since we can actually use both, no? Kasi they are both 7. So since ito na nauna SDBC, SDBCG is our path. Okay, so let's compare SDBCG and SDBEG pala. So since SDBC is 7, we can try navigating SDBCG, papuntang G, which has a heuristic cost of 0 kasi nakapunta na tayo sa goal. But the actual path cost, that is 4 plus 2, that's 6, plus 1, 7, plus 2, that is 9. Okay, 9, SDBCG the path. But in SDBEG, we have an actual cost of 3 plus 1, that's 4, plus 1, that's 5, plus 2, that's 7. This is correct. And a heuristic cost of 0. So the shortest path would be this path here. And this is our final answer using A* search. And I hope that is clear. That's now I would want you to try this on your notes perhaps, or your sketch papers. You can pause this video and try from A to our goal state G. Okay. So I will try to answer this. Sa A to B, lagay natin lahat ng possible paths. A to C. Okay na pa ba? A, B, A, C, wala na. So A to B, heuristic from A to B, that is actually is 1, actual cost. But the heuristic cost is 6, that becomes 7. From A to C, that is actual cost is 4. But the heuristic cost is kani siya ang heuristic cost. So kani 6 ang heuristic. So kani siya is 8. So we choose A to B path here. So A to B na path papuntang D. Walang ibang path, no? Because wala siyang ibang children. A, B. Si D lang at saka si C. So A, B, D. A, B, D. From A to D, heuristic is 3. But the actual path is 3 plus 1, that is 4. Total of 7. A, B, C. We have from A to C, that is 4 heuristic. But the actual path is ABC 1 plus 2, that is 3. Still 7. Tama ba? So let's review A. Ang heuristic niya is from A to C, that's 4. Okay. So both 7. Now let's move to visiting the children of A, B, D, F. Because both are 7, no? A, B, D, F. So from A to F, that is 1 heuristic. Actual cost is 1, 3, 4, 6. This is 7. ADB, ADB, ABD, ABD. Yung children kasi F. Tapos si G. O yan, kita na natin si G, no? So we have 0 ang heuristic cost. But A, padong B, that's 1 plus 3, 4 plus 4, that is 8. Okay. So imagine yung estimated cost is 5, but this is 8. So let's see if this is the shortest path, ABDG. Let's go, tapos na tayo sa ABD. What about sa A, B, C? Kasi 7 din siya, di ba? So, A, B, C, napuntang E. So, estimated heuristic cost is 3. And then that is 1 plus 2, 3 plus 5, 8. Actual cost is 8. So that is 11. Okay, of course, X na yun siya, 11 na. So therefore, our path cost is our path is A, B, B, G with a path cost of 8. So I hope you have the same answer with me. So this is comparison of the search algorithms. Now you may try to take a look at this table. And that will be the end of our lesson for search algorithms. Thank you for listening.